So last class we have discussed about the working of the Carnot engine, and we have seen that the Carnot engine works in 4 strokes: isothermal expansion, then adiabatic expansion, after that isothermal compression and adiabatic compression. So it works in this cycle. It works in this cycle continuously, then we are getting work done during the whole cycle, which will be W1 plus W2 plus W3 and WO. So these are the total amount of work done during one cycle, and we will find out the efficiency of the Carnot engine for this one cycle. And during this one cycle, what is the amount of heat taken? It is taking Q1 amount of heat from the source, and it is giving Q2 amount of heat to the sink. So during the one cycle, the work done will be equal to Q1 minus Q2. Okay. So let us find today the expression for efficiency. So efficiency eta is equal to work done during one cycle divided by the amount of heat taken. So during one cycle, the amount of heat taken is Q1 the amount of heat taken is Q1, amount of heat is giving is Q2. We are going from A to B, then C and then D. The coordinates are P1 V1, this is P2 V2, P3 V3, and this is P4 V4. So these are the coordinates at the point A, B, C and D. This is isothermal expansion, this is adiabatic expansion, this is isothermal compression, and this is adiabatic compression. And this is the process. We have to find out the efficiency now, and to find out the efficiency, we have to first find out the total amount of work done, which is W1, W2, W3 and WO. So now eta can be expressed like this: W is equal to Q1 minus Q2. So as W equal to Q1 minus Q2, so eta will be equal to Q1 minus Q2 divided by Q1, and this will give you 1 minus Q2 by Q1. So this is one expression. That means if I can know the amount of heat taken from the source and the amount of heat given to the sink, then I can find out the eta. So eta will be equal to this much. Then there is another way. W is equal to W1 plus W2 plus W3 plus W4, and Q eta will be equal to divided by Q1. This is another expression, eta expression. So we will go for this one. আমি এতিয়া W1, W2, W3, W4 extra কে উলিয়াম, উলিয়াই পেলাই then we will find out the expression for eta. We also have to know this expression eta equal to 1 minus q2 by q1. So let us find out the expression eta using the work done, and for that we have to find out the work done during the 4 strokes. A plus B लिखे जाते, B plus C, C plus D, D plus A. We have to find out the work done. So that we know, W1 is what? W1 is the work done by the gas during isothermal expansion. During isothermal expansion. But isothermal expansion it is expanding from volume V1 to V2. So it is at temperature T1. So it will be nRT1 ln of V2 by V1. This is the expression for work done during the isothermal expansion. It is going from A to B. It is from volume V1 to V2. So work done expression will be given by this one. Now W2 is a work done by the gas during adiabatic expansion. Adiabatic expansion. Or adiabatic expansion of it is from volume V2 to V3 and from temperature T1 to T2. So the expression will be nR by gamma minus 1 T1 minus T. W2 will be equal to nR by gamma minus 1 T1 minus T2. Temperature is changing from T1 to T2. So as the temperature is changing from T1 to T2, the work done will be, adiabatic work done will be nR by gamma minus 1 at T1 minus T2. So these are all work done during the expansion process. Then we will go for work done number 3, W3. What is this? Work done on the gas. Now it is on the gas because we are compressing it. On the gas during isothermal compression. Now what will be the expression for this? Can you tell me what will be the expression for this? The isothermal compression. So isothermal compression means you are going from V3 to V4. So we are going from V3 to V4. We are going from V3 to V4. So if we are going from V3 to V4, what will be the expression for work done during this isothermal compression? Anybody? Here, minus nRT2 ln of P4 by P3. Is it okay? P3 by P4. Because you see, here যদি আমি expansion করি, if I go for expansion here, আমি ইয়ার যদি expression আছে work done expression আমি কি লিখব? V2 by V1. We are adding V2 by V1. V2 is the final volume, V1 is the initial volume. So during this expansion, if I am going from V1 to V2, now work done is how much? ln of V2 by V1. So here is compress kuru. Now if I go compressing, if I am compressing the gas from V2 to V1, work done expression ki hobo? What will be the amount expression for work done for compressing the gas from V2 to V1? Minus ln of ki hobo? V2 by V1 is not V1 by V2. It is V2 by V1. So similar to this, just imagine that you are expanding from V4 to V3. That means you are expanding the gas from V4 to V3. Now I am compressing the gas. I am compressing the gas from V3 to V4. So it will be work done expression to compression of vector. V3 by V4 because this is the final volume, this is the initial volume. Though I am going like this, initially I expand to expand will be from here to here. So I am compressing from here to here means this is my final volume, this is my initial volume, and my expression will be V3 by V4, not V4 by V3. V4 by V3 নহয়. মই আগৰ ক্লাছত তোমালোকক কৈছিলো এইটো কথা. So while compressing, you have to first make it expand. Expand কৰিব লাগিব তাৰপিছত compress কৰিব লাগিব. Expansionৰ কাৰণে যিটো expression থাকিব work done, compressionৰ কাৰণে work done to same থাকিব but with a negative sign. Okay? So what will be your W4? Work done hobo. This is a work done on the gas during adiabatic compression. We are going from this to this adiabatic compression. So here can work done kiman hobo? What will be the amount of work done? You are going from temperature T1 to the T2. That means you are going from temperature T2 to T1. So the expression ki hobo? Minus nR by gamma minus 1 T1 minus T2. The expression will be remain the same. Expansion of energy expression hoy, compression of energy expression ki hobo? Same hobo but with a negative sign. Baki sob ekar thakibo. Only in negative sign will come. So now if you compare with this W2 ki ase, this is the work done during the adiabatic expansion which is nR by gamma minus 1 T1 minus T2 and adiabatic compression of ki ase minus nR by gamma minus 1 T1 minus. So value is what? Same and with a negative sign. So they will cancel each other. They will cancel each other. Same value going in the opposite direction, so they will cancel each other. So total work done kiman hobo? Net work done during one cycle. During one cycle, net work done kiman hobo? Net work done will be equal to W plus W2 plus W3 plus W4. Now W2 and W4 ಇದು কি হৈ যাব cancel out হৈ যাব. So because this is negative, nRT1 ln of V2 by V1 আৰু W3 to কি আছে minus of nRT2 ln of V3 by V. W2 and W4 already cancel out because they are same, but this is not cancelling out. This is not same because it is here T1, there it is T2. V2 by V1, V3 by V1. So isothermal factor, in case of isothermal, the work done are not cancelling out. But it is cancelling out in case of your adiabatic expansion. Adiabatic expansion or work done to ki hoise cancel out hoise. Hoise ekhine okay. So if it is my total net work done, then efficiency to ki hobo? What will be my efficiency? Efficiency will be equal to net work done divided by the amount of heat taken. So amount of heat taken will be equal to how much? Q1. Etia ghotna to hol ei je Q1 amount of heat loi ase, the Q1 amount of heat is taken during what process? During the isothermal expansion. Aru isothermal expansion karone amar ki dekha pao? From the first law of thermodynamics, I can say that Q1 will be equal to 0 plus W1. Because in case of isothermal expansion, there will be no change in internal energy. So I can write Q1 will be equal to 0 plus W from the first law. and it will give me Q1 equal to W1. So my W expression palu. Q1 I am expressing in terms of W1, which is the isothermal expansion. Here to be shown in this isothermal expansion, whatever heat you are supplying, that is converted to the what? Work. That means there is no loss of energy. 100% efficient. If you see this one, it is 100% heat is converging to the work done. But this is not only the process during a heat engine. Heat engine is all isothermal expansion. If you want to make a heat engine only with isothermal expansion, very good. You will get 100% efficient. But is it possible? If you all isothermal expansion to the heat engine to complete kara, can you able to come back to the initial state? No, it will always expand. But it has to come back. So that is why for a heat engine, it is not possible to convert all the heat to the work done during one cycle. At a portion of the from one portion it may be okay, fine, it is converting to the work. But for the whole cycle, it is not possible. Net will be Q1 minus Q2. This is the amount of heat taken from the source. Efficiency to efficiency is given as the amount of work you are doing. Amount of work is how much? Q1 minus Q2. How much heat the heat engine is taking? How much heat the gas is taking? Kiman heat loy ase? Q1 loy ase. So kiman heat loy ase, kiman work kori ase, that ratio is called the efficiency. বুঝি পাইছে না? যদি আমি এফিচিয়েন্সিটো উলিয়াম নহয়, Q2 টো আমি নাচাওঁ, আমি কি চাম? আমি চাম যে এমাউণ্ট অফ ৱৰ্ক কিমান কৰি আছে হিট ইঞ্জিনটোৱে আৰু কিমান এমাউণ্ট অফ হিট লৈ আছে। That ratio is called the efficiency. That is why this Q1 is coming here, not Q2. Q1 to ল'ব লাগিব। That means that তুমি হিট কিন্তু হিট ল'ব লাগিব the amount of heat that is taken from the source. Because then only I can find out the efficiency, no? By ইমান হিট লৈছো, ইমান ৱৰ্ক কৰিছো। Then only I can get the efficiency. So it will come net work done, then it will, so I can now write the efficiency as efficiency eta will be equal to W by Q1, and W is nothing but NR T1 ln of V2 by V1 minus NR T2 ln of V3 by V4 and divided by কি আছে W1 আছে. Now what is W1? NR T1 ln of V2 by V1. W1 divided by Q1, Q1 is equal to W1 and W1 is equal to NR T1 ln of V2 by V1. So divide করলে ultimately মই কি পাম? Ultimately I will get like this. NR will cancel out. So what I will get is T2 by T1 ln of V2 by V1 divided by ln of V3 by V4. So now my expression for efficiency becomes 1 minus T2 by T1 ln of V2 by V1 divided by ln of V3 by V4. Here I will open steps more possible. What step I will do? Consider the adiabatic equation for B2C and B2A. B2C and B2A kind of adiabatic process আছে, এই adiabatic process to মই চাম. That means I will see the adiabatic equation for this adiabatic part and this adiabatic part. এইটো path আৰু এইটো path equation to মোক লাগিব. So I will consider that equation. So if I consider that equation, can anybody tell me what will be the equation for the adiabatic path from B to C? বিৰ পৰা চি লৈকে এডাবেটিক পাথৰ এক্সপ্ৰেশ্যনটো কি হ'ব adiabatic expression কি হ'ব b to c means you are going from p2 v2 to p3 v3 so adiabatic expression কি হ'ব adiabatic equation কি আছে what is the adiabatic equation pv to the power gamma equal to constant so ইয়াত আমাৰ কি হ'ব এতিয়া p2 v2 to the power gamma equal to constant then p3 v3 to the power gamma equal to constant that means what p2 v2 will be equal to p3 v3 to the power gamma okay so this is equal to some constant this is equal to some constant so they must be equal similarly for d2a কাৰণে কি হ'ব you are going from p4 v4 to p1 v1 so p4 v4 to the power gamma will be equal to p1 v1 to the power gamma okay so ইয়াৰ কাৰণে হ'ব p2 v2 to the power gamma equal to constant ইয়াৰ কাৰণে হ'ব p3 v3 to the power gamma equal to constant so this will be equal to this that means p2 v2 to the power gamma must be equal to p3 v3 to the power gamma similarly ইয়াত যদি চাওঁ ইয়াত p4 v4 to the power gamma will be constant p1 v1 to the power gamma will be constant so these two will be same so that is why I am getting these two equation adiabatic equation p2 v2 to the power gamma p3 v3 to the power gamma equal p4 v4 gamma then equal to p1 v1 gamma এতিয়া এইটো বস্তুক মই টেম্পারেচার আৰু ভলিউমটো লিখিব পাৰো this can be expressed in terms of temperature and volume so if I express in temperature and volume in this situation what is the temperature p2 v2 state or jeta asle gas to whenever the gas in the state p2 v2 what is the temperature t1 so it will be t1 v2 to the power gamma minus 1 I can also express this p2 v2 to the power gamma in terms of temperature and volume it will be like this that must be equal to p3 v3 state of thakote temperature kiman asile what is the temperature when the gas is at p3 v3 state t2 so it will be t2 p3 gamma minus 1 similarly p4 v4 state of temperature kiman ase t2 v4 gamma minus 1 aru p1 v1 state of temperature kiman ase t1 so t1 v1 gamma minus 1 so we have two equations now this and this etu aru etu etia tumi if you divide this equation by this that means if you divide t1 v2 to the power gamma minus 1 equal to t2 v3 to the power gamma by this আৰু হেতু ডিভাইড কৰি তুমি তো উল্টাই লব লাগিব you can come from here to here that means I will divide this by this will give me I will divide this by this t1 v2 gamma minus 1 divided by t1 v1 gamma minus 1 I will divide by this equal to t2 v3 gamma minus 1 divided by t2 v4 gamma minus 1 মই এটো ডিভাইড কৰিছো এটো ডিভাইড কৰিছো so এটো যদি কৰো then this t will cancel out this t2 will cancel out ultimately I will get this will give me v2 by v1 by v1 is equal to v3 by v4 v2 by v1 is equal to v3 by v4 so that expression I got considering the adiabatic expression so it usually হয় তেতিয়া হলে এতিয়া আমাৰ এটো ক্যান্সেল যাব These things will cancel out. It is ln of V2 by V1. This is ln of V3 by V1. Now V2 by V1 is equal to V3 by V4. So therefore, efficiency will be equal to 1 minus T2 by T1, because that things will cancel out. This will cancel out. This portion and this portion cancel out. The same, no? So as it is same, so I got the expression for efficiency as, this is the final expression for efficiency in case of Carnot engine. এতিয়া ঘটনাটো হল, what is the basic objective of the Carnot engine? Basic objective of the Carnot engine to get a engine that will give me 100% efficiency. So itu এতিয়া 100% efficiency পাবৰ কাৰণে what Carnot had did, Carnot কি কৰিছিলে, Carnot has assumed to be ideal. All processes are reversible. There is no loss due to friction and all. The gas he is considering to be an ideal gas. So everything is ideal. So the engine should give 100% efficiency. এতিয়া come to this expression. এতিয়া যদি এই এক্সপ্ৰেছনটোৰ পৰা যদি মই this expression, this eta value যদি মই 1 পাব পাৰো, if I can I get this the value of eta equal to 1, then I can say that the efficiency of the heat engine is 100%. Now T1 and T2 are in Kelvin unit. It is in the Kelvin unit, not in degree Celsius. It is considered as a Kelvin unit. Kelvin unit লোৱা আছে. So যদি Kelvin unit লোৱা আছে, এটা efficiency টো যদি 1 হ'ব লগা হয়, তেতিয়াহলে কেতিয়া 1 হ'ব লাগিব? When the efficiency will become 1? When this T2 by T1 is equal to 0. So if T2 by T1 is equal to 0, then eta will be equal to 1. So efficiency will be equal to 1 only if T2 by T1 is equal to 0. So T2 by T1 equal to 0 যদি হয়, then in that situation only the efficiency will be equal to 1. Otherwise, if T2 by T1 is not equal to 0, then eta will be less than 1. Okay, suppose T2 by T1 is 0.5, it will 1 minus 0.5, it will be 0.5. So 50% efficiency. So this T2 by T1 determines the efficiency of the engine. What is T2? T2 is the temperature of the sink. What is T1? T1 is the temperature of the source. So if you want to make this T2 by T1 equal to 0, there are two ways how we can make this T2 by T1 equal to 0. What are the two ways? দুটা way আছে T2 by T ratio to 0 করব. This ratio will be equal to 0. When the ratio will be equal to 0? T1 is equal to infinite, T2 equal to 0. So only these are the two possibilities. Okay, then T2 by T1 will be equal to 0. So T2 by T1 will be equal to 0. কেতিয়া হ'ব? T1 is equal to infinity or T2 equal to 0 Kelvin. This is Kelvin. Now, is it possible to get a source having infinite temperature, infinite Kelvin? So infinite is not actually defined. Infinite to define korbo nora bostu hoy. So it is impossible, totally impossible. You cannot make T1 to be infinite. Discarded. Can you make T2 equal to 0 Kelvin? That is again impossible. Nobody can attain 0 Kelvin temperature. Okay, minus 273.16 degrees Celsius, কোনো পাব নোৱাৰে. So it is impossible to attain 0 Kelvin. তুমি 0 Kelvin ওচৰলৈকে যাব পাৰিবা. You can go near to 0 Kelvin, but you cannot go or you cannot make it equal to 0. Impossible. In fact, that is the third law of thermodynamics. You cannot attain the 0 Kelvin temperature. Okay. So, duita impossible. it is impossible. This is also impossible. Though duita impossible hoy, that means what? This is again impossible. T by 2, T2 by T1, this is equal to 0. This is again impossible. And it is impossible hoy, then it will Q is again impossible. So, considering the engine to be ideal one, perfect gas, all reversible process, no loss due to friction and all, still your engine cannot give 100% efficiency. So whatever the Carnot has that confidence that okay, I will make a 100% efficient engine, he could not make it. Even the theoretical engine, theoretically also I cannot get 100% efficiency. This is the law of nature. Nature doesn't allow to get an engine having temperature or having efficiency 100%. 100% efficiency heat engine power. But what we can say, the most efficient engine, most efficient engine. ইয়াতকে efficient engine আৰু তুমি নোপোৱা. There are no heat engine which is more efficient than the Carnot engine. Carnot engine is the most efficient heat engine, but it is not 100% efficient. It is not 100% efficient. Okay, it is most efficient. No engine can be efficient, more efficient than the Carnot engine. In fact, that is called the Carnot theorem. It is called Carnot theorem. So Carnot theorem to ki koy je kuno engine Carnot engine ke besi efficient hobo noare. Okay, so even the theoretical engine cannot give me 100% efficiency. So this is what the nature restricts. And এই যে 100% যে হব নোৱাৰে, 100% হব নোৱাৰাৰ অৰ্থটো হ'ল এইটো যে you have to give certain amount of heat to the sink. Okay, তুমি যদি sourceৰ পৰা যিমান heat লৈছা গোটেইখিনি যদি all of the heat that you are taking from the source you are converting to the wall, that means what? 100% efficiency. But even the theoretical engine, ideal engine could not give me 100% efficiency. That means what? You have to give certain amount of heat to the sink. All the heat that you are extracting from the source cannot be utilized to do the work. This is what nature has restricted, and that gives rise to a term called the entropy. We will discuss this later on, entropy. So this is nature bada decision. Nature doesn't allow it. Okay? So we are getting the expression as theta equal to 1 minus T2 by T1. We are also having the expression already 1 minus Q2 by T1. Q2 by T1. So these are the two expressions. Etu eta hobo pare. So if you make it Q2 equal to 0, Q2 equal to 0 কৰাৰ লগে efficiency কিমান হৈ যাব? 1 হৈ যাব. That means 100%. So you cannot make Q2 equal to 0. You have to lose. You have to burn. Heat engine has to lose certain amount of heat. This is what nature allow only. Nature into allow kori ase. Hobo etia ghotnaটো হল যে okay fine, I am not getting efficiency 100%, but what I can do, I can increase the efficiency. When eta heat engine efficiency to বঢ়াব পাৰো, এটা কেনেকে বঢ়াব পাৰিম? So if I want to increase the efficiency, this value has to be very very small. So T2 by T1 should be very very small. If T2 by T1 to তুমি কেনেকে small কৰিবা? You cannot make it equal to 0, but you can make it small. So how you can make this T2 by T1 small? কেনেকৈ কি ৱেট তুমি কৰিব পাৰিবা T1 টো তুমি বঢ়াই দিব পাৰা ইউ কেন ইনক্ৰিজ দ্য ভেলু অফ দিছ T1 অৰ উল্টাটো তুমি কৰিব পাৰা ইউ কেন ডিক্ৰিজ দ্য ভেলু অফ T2 so T1 অৰ ভেলুটো বঢ়োৱা মানে ইউ আৰ ইনক্ৰিজিং দ্য টেম্পাৰেচাৰ অফ দ্য সোৰ্স ইউ আৰ টেকিং এ ভেৰি হট সোৰ্স খুব হট সোর্স লৈ আছে আৰু T2 টো কমোৱা মানে what you are doing you are taking a sink or very very low temperature so it is easy for people to make a sink at lower temperature compared to taking a source at very high temperature মানে খুব হাই টেম্পারেচার দ্বারা সোর্স লোৱাতকৈ খুব লো টেম্পারেচার মধ্যে এটা সিঙ্ক লওঁ it is more suitable for human being সেইকাৰণে though I can increase the efficiency by increasing T1 or by decreasing T2 I will prefer to the second one so heat engine যেতিয়া বনোৱা হয় heat engine বনালে কি কৰা হয় T2 টো যিমান পাৰে কমকে ৰাখা হয় compared to the fact that T1 টো বেছি কৰি ললো T1 টো বেছি কৰি ৰাখা মানে কি তাক মেইনটেইন কৰি ৰাখাটো এটা প্ৰবলেম হ'ব না হায়াৰ টেম্পারেচাৰ টা মেইনটেইন কৰি ৰাখা ইট will affect the surrounding so তুমি কি কৰিবা T2 will be maintained at lower temperature and thus you can increase the efficiency of a heat engine this is what the Carnot heat engine আৰু Carnot heat engine পৰা আমি এটা কথা গম পাওঁ যে whatever be the situation whatever be the conditions the heat engine has to give certain amount of heat to the sink which is not usable Q2 is not usable it is given to the sink so certain amount of heat always you are losing whenever you are running an engine certain amount of heat you are dumping to the sink it is which is not usable it is not usable heat engine pe heat use korbo na heat engine kontu heat use korbo pare it can use the heat in the source it cannot use the heat of the sink or sink to the use korbo laga bahiror pora tumi ki dibo lagibo energy dibo lagibo which is nothing but your refrigerator okay so let us stop it here today